touches the circumference of a circle at only one point. That's a tangent. Okay? So the first theorem on tangents is that a tangent and a radius are perpendicular to each other at the point of contact. Okay? So a tangent to a circle is perpendicular to the radius at the point of contact. So if you draw a circle, you draw a radius from the center, obviously, to the circumference. Then you draw a tangent such that it comes into contact at this point here where the radius is, or where the end point of the radius is on the circumference, right? The angle formed between the radius and the tangent is going to be 90 degrees. Okay? And that reason is we call it tan perpendicular to radius. Tan perpendicular to radius. Okay? We call it tan perpendicular to radius. Right? Also, since the radius is half of the diameter, we can also write it as tan perpendicular to diameter. So a diameter and a tangent are perpendicular at the point of contact. Okay? So you can choose which way you prefer. Generally, I prefer to write my reason as the first one. But if you replace the radius by the diameter, it's also acceptable. So this is the diagram for that. Okay? So both angles, like in this case, B1 and B2, they are both 90 degrees. Now, this theorem here, it is very useful when you do grade 12 analytical geometry because it is required when you are dealing with the equation of a circle. All right? Then the converse now. The converse now says if a line is drawn perpendicular to a radius at the point of contact, right, where the radius meets the circle, then that line is a tangent. So if you draw a line from the center of the circle, such that you've got your radius there, then you draw a line which comes into contact with the radius. If the angle between them is 90 degrees, then you can say the line is a tangent. So we use converse of of theorem 7 to prove that a line is a tangent. If you practice a lot, you are going to encounter questions where they will ask you to prove that a line is a tangent. Okay? So how do you know? You just use the converse of theorem 7. If a line and a radius are perpendicular, then you can say that the line is a tangent to that circle. Okay? And the acceptable reason, okay, generally for this one here, we can write line perpendicular to radius, which is not my favorite. My favorite is converse tan perpendicular to radius. Okay, this is my favorite. There are two reasons. The Honda prefers this one here. Okay, but if you write line perpendicular to radius, it's also acceptable. So I prefer to write converse tan perpendicular to radius because it's in direct relationship with the original theorem 7. So theorem 7, tan perpendicular to radius, the converse line perpendicular to radius or converse tan perpendicular to radius. Okay? So this converse, we use it when you want to prove that a line is a tangent. I'll give you a question like that, where you're supposed to prove that a line is a tangent. Okay? Any question? Okay. How many of you are going to be? I'm gonna attend the M lesson. Okay. If you did not get 8% or more and you are not gonna be there, please just provide me some reasons why. Don't just go. Okay. But if you got 80% or more, you are more than welcome to not tell me. Yes? Yes, up to 3:30. And please, the M lesson, no new work will be covered. I'm gonna go over the standardized test. Okay? Alright. Any question? Can I carry on here? Right, I just need to talk about maybe theorem 8. Okay? Yes. Okay. Uh, well, what I would say is there are about 9. Okay, sorry, I'm saying, yeah, 9, right? 9 first. 9 main theorems, 9. Then you have got the converses, right? Converse of theorem 1. There's no converse for theorem 2. Converse for theorem 3, converse for theorem 4. So we are now numbered what? 12. Converse of theorem 5, that's 13. Converse of theorem 6, that's 14. Then converse of theorem 7, that's 15. Then we have got theorem 8, there's also a converse. So we are talking about, and then we have got the equal chords as well. There are 3 of them. Equal chords subtend equal angles at the center and at the circumference. Equal chords that belong to equal circles subtend equal angles at the center and so on. Right? So we've got those 3. So total to be around, maybe I would say 19, right? Including the converses and the equal chords. Okay. But remember, the equal chords, they are called corollaries. They originate from a theorem. But I'm just including them in total. Okay? But the main theorems are 9. Based on your curriculum in grade what? In grade 11. Alright. Theorem 8. So what I'm going to do, I'll talk about this one here. Then our lesson will stop. Tomorrow, I'll talk about the mother of the tangent theorems. That's one, because it has got a proof. That's how I'll talk about that one tomorrow. Now, theorem 8, right? According to theorem 8, if you draw